Hello, guys. Welcome to Ramta Solutions. Welcome to your statistics video on variance and standard deviation. In grade 10, you learned about measures of dispersion that included your quartiles, percentiles, and range. So, variance and standard deviation are also other types of measures of dispersion. Okay, there are also other types of measures of dispersion. So, what are these two really looking at? What they are looking at, they are basically showing you how much how much values in a data set are varying from each other, and also how much are they different from the mean itself. Okay. All right. So now, what we are going to do now, we are going to look at each and every one of them before we do an example. So I'm going to give you a brief on variance and a brief on standard deviation. Of course, also giving you some formulas as well. Okay. So now let's begin with variance. Okay, we will begin with variance. So what can we say about variance? Remember, they are basically giving us information on the spread of data around the mean, right? That's what they do. So now what we are going to do, we are going to look a bit at what each and every one of them do. So this variance, we symbolize it with sigma square. Okay. This one is a sigma. This called a sigma. Okay. It is different to that one that you know for sum of. Okay. I know this one is also sigma. Okay. So this variance is symbolized with the letter sigma square. So what does it do? We said to you, it'll show how much values in the data set vary from each other. All right. Let me just say this, how much values in a data set vary from each other. Okay. From each other. That's one thing you should know as well. Okay. So, and then what else can we say? What else can we say about this variance? Yes, we are basically saying it'll show us how much values in a data set vary from each other, right? That's what from each other. All right. Now, what this is really saying? It's basically saying to us, it is telling us how far each number is from the mean and from each other. Okay, it is telling us how far each number is from the mean and from each other. Okay, so what happens when you have let's say you have a high variance. What is the meaning of a high variance? The meaning of a high variance, what does it mean? It means your data is further from the mean, right? It means your data is further from the mean, right? Now, what does this mean? What does this mean exactly? So this means that the data values, right? This means the data values have a high variability. Okay, data values have a high variability. They are so different. Okay, they have a high variability. This means the values are so different. Okay, what does that mean? That means these data points are widely apart, in other words. Okay, now let's then look at when you have a low variance. What does it mean if you have a low variance? If you have a low variance, it means data, this one was further from the mean. So what is happening with this one here? This one here, we can say this one is closer to the mean, right? So this data is closer to the mean, isn't it? And if it's closer to the mean, what does it mean? It means here the data points, or let me say values, data values are clustered. All right. When we say they are clustered, they are so close together, right? Are clustered. That is to say, they are closer together. Okay. All right. So this is what it means when you have your variance. Okay. Now, let me give you this. This equation of the variance is this: sigma square is equal to sum of terms. Let me say I equals 1 to n of data set minus the mean all square all over n. So this is the formula that you're going to use in your high school, guys. Okay, this is the formula that you're going to use in your high school. Normally we say this applies to a population. Okay, this is the formula that you are going to use in high school. Okay, this is the formula that you are going to use in high school for a variance. Okay, now this variance, I need you to see something here. We need to ask ourselves, what are then the units of variance, and can the variance be zero? As you can see from this formula, we can see that. Can you see that? We can see from this formula, can it really be zero? So we then say, nah, the variance can never be zero. Okay, saying the variance can never be zero. Okay, now what about the units? The units of your variance will be whatever unit you're considering square. Okay, the units will be whatever unit you're considering squared. Okay, that will be the units of your variance. Now, let's look at your standard deviation. Normally, this variance is used with standard deviation, right? This variance is used with standard deviation. So now let's look at standard deviation. So standard deviation. So standard deviation will just be sigma. Okay. So what is this? This therefore says standard deviation is the square root of the variance. All right, it is the square root of the variance. All right, it is the square root of the variance. Remember, we said standard deviation, variance, they are measures of dispersion, right? We said they are measures of dispersion. So this standard deviation, it can also be referred to, maybe we can say it is also a measure. It is also a measure of uncertainty. It is also a measure of uncertainty. Okay. It is also a measure of uncertainty. Okay. It is also a measure of uncertainty. So what is happening with this one? They show how far apart data values in a data set are from the mean. Okay. It shows how far data points, let me say data points or data values in a data set are from the mean. Okay. From the mean. Okay. How far apart data points in a data set are from the mean. Okay. So like we said about the variance, let's talk about the standard deviation. So a very small or low standard deviation low standard deviation. Let me see how I introduce that. Okay, low standard deviation. So small standard deviation. What does it mean? When you have a low standard deviation, what does it mean? It means this is basically closer to zero. It means all data is clustered, just like we said, right? All data is clustered, right? What do we mean by this? We mean that there is little variation. For example, there is little variation, all right? There is little variation. And what else are we saying? We're saying data values are closer to the mean or data points. What did I say there? I said data points. Okay. Data points. Data points are closer to the mean. Okay. Now let's look at a large standard deviation. So this is one that's, say, greater than 1. Remember, this one is less than 1, closer to 0, right? So what about a large standard deviation? So a large standard deviation, what is happening? Just like we said in variance, these data have high variability, right? So data points have a high variability, have a high variability. So this is to say they are far apart, have a high variability, and therefore these data points are far from the mean, right? Let me not use the word far, but these data points are spread out from the mean. Maybe that's better. Are spread out from the mean, right? This is what we need. So sometimes when you look at your data, it's important that when you are asked for standard deviation, you then first and first you will need to get your average, your mean, right? And then you look at your mean, you can see that, oh, okay, you can see that indeed what is happening here is this. What is happening here is that we have you can expect rather a small standard deviation or a large standard deviation. All right. When you look at your data, comparing it to the mean. All right. But now, what is the formula that we use for standard deviation? Remember, we said it is the square root of the variance. Therefore, standard deviation, if you recall, we said the mean, let me remind you, forget the square. The variance was this part here, square, right? Squared, but the sum of, if you recall, x sub I minus x bar all square all over n. But now, because we're talking standard deviation, we said it is the square root of the variance. So standard deviation will be this guy here. Okay. And let me write this in the center. Okay. Let me write this in the center. In the center. Oh, and the bigger font size. This will be, okay, n xi minus x bar close all square all over n, but you are saying the square root of it. All right. So this is the formula of your standard deviation. Right. This is the formula of your standard deviation. So what we're going to do now, we're going to try an example. Okay. We're going to try an example and we will confirm the answers that we will get with how the calculator shows. Okay. Or what the calculator gives. Example, determine the variance and standard deviation the variance and standard deviation of the following data, of the following data, right? Of the following data. So which data should we use? I have different types of data that I should. Okay, let me try this one here. I want to try maybe small um size. I want to try small size. Maybe let me try okay, let me try okay, of the following data. Let me try 1, 2, 3, 7, 10. Right? So let's try this. Now, what we need now, let's see if it's possible. I may need to go to the next page. Okay, I may need to go to the next page. I need you guys to see this. We're gonna draw a table, remembering the formulas. So in our solution, I need you guys to remember the formula. This formula for standard deviation. All right. I need you guys to remember it. I'm gonna share something just now. Do you see already we have the x sub i's here? This is the data point in our data set, right? Now we need the mean, which we call the average, and we need the distance between data points and the mean and the square of it. Okay, so now let's see. So we'll say in our solution, we'll say we have x. I see it. Maybe let me use grid lines. Okay, that's better. I think they too. This is better. So now I'm gonna say we have x. We had 1, 2, 3. Did we have 4? No, we had 7 and then 10. Now we will need xi. This is xi, by the way. We will need xi minus x bar. Okay. Then we will need xi close in bracket xi minus x bar close square. Okay. And then what I will need to do here. Okay, so this is it. Okay, so now let's see. We need to find the mean here. What is the mean? The mean will be x bar equals sigma xi over n. So what is this? This 1 plus 2 plus 3 plus 7 plus 10 all over how many points are here? 5. So what is this? We have 10, 20, 23 out of, we have 23 out of 5. So what is 23 out of 5? It looks like it'll be 4 comma 4 comma what? Maybe 4 comma 6. Yeah, maybe 4 comma 6. Let me confirm. 23 divided by 5 will be 4 comma 6 indeed. Our mean is 4 comma 6. Okay, our mean is 4 comma 6. All right, so remember this portion here says x bar minus xi minus x bar being the mean, right? So what do we need? What we need now, we need to say what is 1 minus 4 comma 6. It'll be minus 3 comma 6. 2 minus 4 comma 6. It'll be minus 2 comma 6. What about 3 minus 4 comma 6? It'll be minus 1 comma it'll be minus 1 comma 6. And then talking about 7 minus 4 comma 6, it looks like it'll be 2 comma 4, right? It'll be 2 comma 4. And then 10 minus 4 comma 6, it'll be 5 comma 4. Yeah, it'll be 5 comma 4, right? Now, what do we need? We need to get the squares of, I think I can remove these lines now. Now we need to remove the squares here. We need, and oh, let me take this a bit down. Now we need to remove, not to remove, man. We need to get the squares of this difference. So let's see. 3,6 squared, I can even press 3,6 as is. It won't matter because negative times negative is positive. So here we get, oops. So here we get 12,96. Now 2,6 square, we get 6,76. 6,76. Then 1,6 square, we get 2,56. 2,56. 2,4. Yeah, 7 minus 4,6. Indeed, it's 2,4. Now 2,4 squared, it's 5,76. 5,76, right? 5,76. Now 5.4 square, it gives us 29,16. 29,16. All right? 29,16. Now, this total here, maybe let me just get, say, total here. This total here, let's get it. 29,16 plus 5,76 plus 2,56 plus 6,76 plus 12,96. What do we get? We get 57,2. So this here is 57,2. This is 57,2. So you can see this is the sum of the square of the distance between data points and the mean. Right? Now, what did we say about our variance? We said our variance, right? For variance, we said it is lower sigma being equal to upper sigma I equals 1 to n xi minus x bar all square all over n. What was this part here? The sum of the difference, the distances between data points and the mean. We found it to be 57.2. So it has 57.2. And how many data points are there? There are 5 data points. So let's see. 57.2 divided by 5. What do we get? We get 11.44. That is our variance. Ooh, so as you can see, this variance is very large. What does it mean? What does it mean? It means that the values are not clustered around the mean. Now let's confirm maybe with the standard deviation. So with the standard deviation, let's see. With the standard deviation, we'll say this guy here equals the square root of whatever we had there, right? Let's write the formula first. It's important. I equals 1 and all over r. So what is this? This is 57,2 all over 5. Right? So what do we get? The square root of the previous answer we got. So we can simply say answer, what is this? It is 3,38. So the standard deviation is 3,38. What did we say? This standard deviation is 3,38. Now let's go look at each individual point. Look at this one here. 1, is it closer to the mean? No, it's far. 2 is far. 3, a bit closer, but a bit closer, but we can still say far. Now look at 7, far from the mean. 10, far from the mean. So it is not surprising that we have these values here. Remember what we said? We said when the standard deviation is bigger or larger, data points have a higher variability. Indeed, that's what we had. Let's go also check with our variance. When you have a high variance, it means data points are further from the mean. That's what we found. So they have a high variability as well. Do you guys see this? So this is your variance and standard deviation. Okay, so these values, without even making calculations, further calculations, when you have your mean, you can then compare and say, okay, it seems like this data will have a low or high standard deviation, a low or high variance. Can you see that? All right. Now let's confirm these results with our calculator. I'm going to use Casio calculator. Okay. Okay. So here is our Casio calculator. Okay. So here's our Casio calculator. To get to statistics, we will need to go to mode and then select stat, which is number 3 for statistics. By the way, guys, this is on Casio FX991 ZA plus 2 emulator. Or normally your calculator is not saying emulator. So it is, this one here is FX991 ZA plus 2. The very same thing is working for any Casio calculator. But of course, the values here might be slightly different. So let me start afresh. We said we go to mode and then we locate stat. In my calculator, it's saying it's option 3. Then under stat, we're going to go to VAR variance. Okay. 1, it's option 1. Right. Now, when you insert the data, you press the data point you want, which is 1. To enter it, you press equal to. And then I'm going to press the second one is 2. Enter it. Remember, you press equal to. Press 3. Entering it. 4. Entering it. 5. Though we didn't have 5. Sorry. Let me delete this. And then we didn't have data point 4, isn't it? We didn't have data point 4. So I'm going to fix this. Okay, I'm going to fix this later. So we will say, let me just continue. We will then say 10. Okay, we'll then say 10 because I made a mistake there. Now, as you can see, I've entered. I'm going to fix by scrolling up. I'm going to fix that 4. In place of 4, I'm adding 7 and then equal. Okay, do you see that? Now, scroll up to confirm your data. 1, 2, 3, 7, 10. How many data points did you say we have? Indeed, we had 5 data points. You can press AC. Now, to get all these things that you want, for example, we are interested only in the mean. So we're going to say shift and then press 1 that says statistics or distribution. So we're going to say shift 1. It gives us 1 type, 2 data, 3 sum, 4 variance, right? So if you like, you can also check the sum of your terms. Maybe let's confirm. I'm going to go to sum, which is option 3. I'm looking for the sum of data points, which is upper sigma x, right? So I'm going to say 2. It must give us 23 if it's correct. Let's see. Indeed, it's 23. Do you see that? I'm going to press AC to clear my screen. Even if you don't press it and continue by pressing shift 1, it's okay. So now I'm not looking for this. So obviously, since you said it's 23, you know the number of terms. Again, if you're looking for the number of terms, you can say number of shift. Let me try 2. This is our data if you want to edit it. Can you see that? Ours is fine. Again, press AC. Now we're going to press shift 1. Now I'm going to go to 4 for variance. How many points does our data have? I'm confirming that. Our data has 5 points. Indeed, it's 5. Therefore, easy, you can say 23 divided by 5. What is it? It is 4,6. But since you can have this already calculated, you can simply say shift 1, then you go to variance, right? Variance, what are you looking for? You're looking for the mean. As you can see, X bar, it's option 2. You go to option 2. Then what is this? This is, you see, 4.6. So our calculator gave us the correct mean value. So we are good. Press AC once again. What are we looking for now? We are verifying our variance and standard deviation, right? We are verifying our variance and standard deviation, right? So we're going to say once again, shift 1. Right, we're going to say shift 1. And what are we looking for? Once again, we go to variance. Under variance, we're going to use option 3 to say standard deviation of the values of x. So we say 3, let's confirm, equal to, what is it? 3,38. Do you see that? Correct to 2 decimal places. So our standard deviation is correct. Now, to get our variance, what do? We just square our answer that's already displayed. Check this out. I'm not pressing anything else but a square to say the previous answer. I'm squaring it. After squaring it, I press equal sign. And what did we get? 11,44. So what's tempting is you can try 3,38. Maybe it might give you something different, right? 3,38 squared. If you try it, 3,38 squared, what did it give you? What did it give you? I want you to check it out. So we are fine now, right? So now the reason why it's important to not round off J, it's important that unless if the first question, the final answer was 11,44, then cool, you can just find the square root of 11,44. Okay, so now from your calculator to find your thingy, say you found your standard deviation, it will be tempting to say 3,38 square. Check what you're getting, 11,42. You see the difference there is because of the rounding that you had here. So it's important that you don't do that, okay? All right, guys, this is how you calculate your standard deviation and your variance manually and using your calculator. All right, bye-bye.